from American High School, and the project I've been working on is a knee rehabilitation device. So the reason I chose this device is because I've had a lot of knee injuries in the past, some of them due to squats, and I'm also interested in the biomechanics behind the squat. So what this device does is it detects incorrect form and alerts the user by making a buzzer go off. And the way this works is that I use an accelerometer to gather values, and if it hits a certain value, if the accelerometer reads a certain value, then the buzzer will go off. I'll start off with a live demo of how it works. First, I'll show the accelerometer, which is this thing right here. It's an accelerometer and it doubles as a gyroscope, so it can read rotation also. So I'll start by plugging it into the power bank to send power to the Arduino. Alright. I'll start off with a few good squats where the buzzer should go off at the bottom of the squat, telling me to come back up. So how the accelerometer detects if I'm at the bottom of the position is it reads values in the X, Y, and Z direction, where the Z is up and down, the X is front and back, and the Y would be side to side. So the way it detects I'm at the bottom is when the Z acceleration is the same as the acceleration due to gravity, which is 9.8 meters per second squared. Now we'll show bad form where my knee bends inward, which it shouldn't, because that puts stress on my knee and my hip. So I'll start off by showing just like some rotations and it starts beeping. Now I'll start doing some like actual bad squats. So yeah, that shouldn't happen, and that's it. So to be more detailed on how it works, the way I assembled this was by sewing my Arduino and accelerometer onto my knee sleeve. And the Arduino is a controller that reads an input, which in this case is a buzzer, or in this case is the accelerometer, and then it creates an output, which in this case is the buzzer. The accelerometer again reads values from X, Y, and Z, and to detect whether the knee was moving inward, I use the Y value acceleration, which would be side to side again, and I also use the gyroscope, which rotates rotating motion, because the knee naturally rotates when it's bent inward. Some challenges I had with this project were calibrating my accelerometer, because the accelerometer tutorial online was outdated and it didn't work with the current Arduino IDE. So I used the calibration code for a different accelerometer to make it work. Also, I mentioned I sewed my Arduino onto my knee sleeve, and since the threads were pretty thin, the threads often kept breaking, and I had to reinforce it with a lot more sewing. It also took a long time to find accelerometer values to detect if my knee was moving inward, so it was a lot of trial and error. Next up for my project, I have to add a squat counter, a timer for a wall sit exercise, which is where you lean against the wall and hold a squat position. And the hardest one would probably be a step counter, which would be hard because it's a completely different movement than a squat. Entering Bootcamp, I didn't know a lot about hardware and circuits in general. I learned a lot about coding on the Arduino IDE, which primarily uses C++, which is pretty similar to Java, which I had experience in the past. And I also learned website development tools to make my portfolio look more refined and better. Overall, my time at Bootcamp has been enjoyable because I met a lot of new people, and I've also been exposed to new technologies which I haven't been exposed to before. Thank you for listening.